So today we're going to look at transistors, probably the most important electronic device ever invented. Here's some a few transistor cases. They come in a variety of cases. These are kind of the most common, but there's way more than what's here. And transistors are important because they act as switches and as amplifiers, and they're in pretty much everything nowadays. Broadly speaking, there are two classes of transistors. There's the bipolar junction transistors and the field effect transistors. We're going to be focusing on the bipolar junction transistors in this video. And there's two types. There's NPN and PNP. The field effect transistors break down into junction FETs and MOSFETs. These also break down into more categories, but since we're not looking at those, we won't worry about it. The symbols for the transistor. Now the BJT transistors look like this. Now for the NPN transistor, the arrow points out. For the PNP transistor, the arrow points in. And you'll see on this schematic here, it says E, B, and C. That's because this with the arrow on is the emitter. The C is the collector. And B is the base. And a small current on the base controls the current between the collector and the emitter. And this can be a much larger current than this little tiny current that comes into the base.
So in this circuit, we have an NPN transistor here, and it's hooked up to an LED. And so the power comes in, goes into the collector and out on the emitter out to here. And the base is hooked up to this switch and a 10 ohm resistor, which brings it to ground. And when we push the button, the light comes on. So what happens is when we looking at conventional current, when we provide conventional current to the base, the NPN transistor turns on. And we take the conventional current away, the transistor turns off. So this is showing the switching aspect of a transistor.
So let's take a look and see what was happening with our NPN transistor. So this is kind of a look at what an NPN transistor is. There's N-doped material, P-doped material, and N-doped material. The P-doped material is between N and the two N's. Our emitter is here, our collector is here, and our base is here. Now, when we look at positive current, or conventional current as it's called, the electricity looks like it comes in through here, goes through here, and then out here. But the reality is the electrons, so the negative electrons, want to go this way. They go this way, all right? Now what happens, now the N material, there's lots of electrons, extra electrons. It's doped to have extra electrons. Whereas the P material has holes for electrons. And just like in a diode, there's a depletion region between these two, in this area here and here. And these are doped in such a way that this depletion region is smaller than this depletion region down here. So as these electrons try to fill up the holes in this depletion region, they kind of get stopped because there's not enough to go through. So what we do here, and if you remember, we had this going through a resistor to minus, and then through a switch to plus. So when we have this resistor here, electrons are trying to get in this way here, which further blocks things up. However, when we press the switch, this takes electrons from here and takes them off to the plus, meaning there's now room for electrons to come in like this, and then go all the way, and some of them sneak off this way, but most of them actually get through all the way and then come out here, and we've turned the transistor on. So we have the positive for the battery over here and the negative here as well. And that's how the NPN transistor does its business.
So this is the same circuit, except instead of an NPN transistor, we have a PNP transistor. And it's hooked up the same way. So we have positive going to the collector, emitter connected to this LED, and the base is connected to this switch and to this resistor. Now the resistor is tied to ground, and right now this is not getting any positive, any conventional current. So if I push the button, the transistor gets conventional. So right now the transistor is on because it's letting power get to the LED. But when I push the button, the transistor is now getting conventional current, and now it's off. So that's no longer allowing current through. On, off. So in essence, PNP operates opposite an NPN. Now we can make a PNP transistor act like an NPN transistor. In other words, like this is set up here, so when I push the button it comes on. We just have to basically hook it up backwards. So now we have the emitter is directly connected to negative. The collector is connected to the negative side of our LED, which then goes through a resistor to the positive. And the base is now connected through a resistor to positive, and then when we push the button, it gets connected to negative. And there we go.
So we notice that the PNP transistor operates differently. It operates basically reverse. And the P areas have holes, just like before. And the N has excess electrons. Now when it's operating, when we have it hooked up, say, correctly, and working the same way an NPN does, in other words, we turn on the N bits. If you recall, we had this going through a resistor to the plus, and then going through a switch to the minus. And then we had, instead of having our LED going this way to minus, we have it going the other way. So this is now hooked up to plus, and this is hooked up to minus. And so the electrons want to go this way now. But we now have too many electrons in the middle, so they can't get through there. And this peels a little bit of them off. But when we add it, it pushes them through like that. And then we get the current going this way. So basically this works in the opposite way that the NPN does. So if we hook it up the same way the NPN does, it works opposite. In other words, when we give positive current to the base, it lets things flow because it's taking electrons. And if we hook it up properly, we have to basically tie this to minus to turn it on.
So this setup, we have an NPN transistor here. It's hooked up through a 100K resistor and a 100K potentiometer to plus on its base, and then its collector is connected to positive, and emitter goes through a current limiting resistor to an LED. Now the LED is on because the power supply is on and there's some current coming through. This multimeter is measuring the current that's going into the base. So it's 22.6, in this case, microamps, so millionths of an amp. And this multimeter is connected to the current that's going through the transistor out through the diode, and it's currently at about 4.6, 4.7 milliamps. So we have a very, very small current here in the microamps, millionths of an amp, and it's allowing 4.7. Now as I turn this, the current will increase here. So we're now up to 26 microamps. We've got a whole 5 milliamps now, and as I increase this up, it'll max out around 3.2, but I'm getting 6.7 milliamps. So 32 microamps of current is letting this transistor push out 6.7 milliamps. So a very, very small current is controlling a much larger current. And that's the other function of a transistor, is amplifying. So it's taking this small signal, and very, very small changes in this signal cause a very, very large change over here. So we've got 4.7 milliamps and 2.26. So if we put this up to 2.36, like so, well, 2.36, we're now up to 4.9. So a increase of 1 microamp has caused a large increase there. If we go to, say, 2.5, and we're up to 5 milliamps now. And now we're a whole milliamp stronger, but we're only a few microamps stronger here. So a very small current can control a very large current, and that's amplification, and that's another function that transistors do. Cool thing you can do with amplification and switching with transistors is a little circuit like this. So I've got two NPN transistors here. Right now this one's not really hooked up to anything. This one's hooked up to the positive of the power supply, which goes to its collector. Its base just goes to this wire and then goes through this current limiting resistor through the LED to minus. And if I touch this, nothing happens. Okay. So what I'm going to do is I'm going to plug this in to the other transistor here. So now the base of this transistor goes to the emitter of this transistor. Now this transistor, the collector goes to plus, the base goes to this guy, and the emitter connects to the base here. Now if I touch this, the light comes on. So what's happening is my body collects some, because we have AC electricity all over the place, my body acts as a bit of an antenna. So what it's doing is it's taking some of the energy that comes in the form of from the AC in the house here, and when I touch it, it creates a very, very small current. Not enough to turn this transistor on completely, or at least enough to turn on this LED. But when I put the second transistor in, that takes the very small current that I generate, and then takes it and amplifies it. Amplifies it using the current coming from the power supply, and that gives enough current to turn this on enough to turn on the LED.